Class, welcome back to our last video of the first part of Chapter 6. Alright, so this is our last video before we take a little test on 6.1 through 6.3. This video is a lot of, well, some of the same, but then also just some extra questions, other types of problems that we can solve using trig functions. Alright, so to start, please recall what is a coterminal angle, or sorry, what are coterminal angles? Well, coterminal angles are angles that share a terminal ray. And I'm also going to put slash side, because sometimes we don't think about it as a ray. But yeah, alright, so like this angle right here, which is like a 45-degree angle, and this angle over here. Alright, if I go straight out, but now I go over here this way, we call those, can we see? Yeah, those are coterminal angles. Why? Because they have the exact same terminal ray, and they have different angles to get there, different paths. Alright, so that idea is needed in example 1, at least for a couple of them. Guys, I did not teach you about 17 pi over 4 on the unit circle, but we did, and hopefully we remember this, if we're talking denominator of 4, well, we know all the way over here at 180 degrees is 4 pi over 4. Alright, all the way over here is 4 pi over 4. So that means I can go 4 pi over 4, 8 pi over 4, 12 pi over 4, 16 pi over 4, and then just one more, 17 pi over 4, to understand where I am. Because now I know that 17 pi over 4 is coterminal with pi over 4. Alright? And, well, pi over 4 we can work with. We know the sign of pi over 4 is root 2 over 2. Okay, so understanding coterminal angles is super important. We can turn any angle we want into an angle within our original unit circle that we have memorized now, just by spinning around, okay? So what happens when we take a look at cosine of 5 pi? Well, it's going to be the same type of thing. I might draw a little picture, and I know that I have pi, 2 pi, 3 pi, 4 pi, 5 pi. So I know that I'm over here straight to the left, and I know when I'm out straight to the left in the unit circle that my x value, which is cosine, right, is -1. Alright? The next one should not be a big deal. We know where we know where 5 pi over 4 is. 5 pi over 4, if we drew the picture, would be 4 pi over 4. Okay, straight down. And what's going on here? Tangent, tangent, tangent. Tangent is y over x, or sine over cosine. Well, the sine is negative root 2 over 2, and the cosine is negative root 2 over 2. So what is negative root 2 over 2 all over negative root 2 over 2? Everything cancels, and we just get 1. Alright, now this seems like a good stopping point for a second. I want to skip down just so I can have a little bit more room. I want you to notice something, that in quadrant 3 tangent is positive. Alright, tangent is positive. There's a little trick here that I think might be helpful. We're going to do it down at the very bottom of the page. And it has to do with quadrants. It has to do with quadrants. We know that in quadrant 1, our points will always be positive, positive, and in quadrant 2, we should always be negative, positive, and 3, negative, negative, and of course, in quadrant 4, positive, negative. Well, there's a little trick, and it's a phrase. It's all students take calculus. And what it is, and let me write that out, all students take calculus. This is a trick for determining determining what is positive. All right, and if you think about it, A stands for all, everything, right? Sine, cosine, tangent, all going to be positive up in quadrant 1. Well, what happens when we go to quadrant 2? The only thing that's positive is sine. Cosine is going to be negative, and of course, a negative divided by a positive, or sorry, excuse me, a positive divided by a negative is going to be negative. All right, so the only thing positive is sine, S for sine. Down in quadrant 3, the only thing that's going to be positive is tangent, right? Both sine and cosine are going to be negative. And then down in quadrant 4, we can say that just cosine. All right, so all students take calculus. This might be helpful, especially for something if we kind of go back to letter C. We understand already because we are in quadrant 3, we know our value has to be negative, or sorry, excuse me, positive. So if we got something negative, we would know that we'd have to kind of take a look at it again. All right, okay. Let's move on. So in question number 2, I know that sine is less than 0 or negative, and I know cosine is negative. Name the quadrant. All right, well, let's think about this. If sine's going to be negative, what does that mean? What can we get rid of? It can't be the top, 2 or 1. And if cosine is negative, well, then it can't be 1 or 4. And so we notice that the answer, the quadrant in which the angle lies, is quadrant 3. All right, so these types of problems are pretty easy if we understand what it means for sine to be less than 0 and cosine to be less than 0. All right, okay. All right, next problem. I'm given a sine, I'm given a cosine. It doesn't look like it's going to be on the unit circle, so let's take a look at this. And let's remember that sine, if it's on the unit circle, is y. But if it's not on the excuse me, if it's not on the unit circle, then it's y over r. So think about this with me, guys. I can say that my y value is the square root of 5 and my radius is 5. So I'm going to draw this picture. All right, I draw my triangle. Here's my theta. I know that my opposite over hypotenuse, or y over r, is square root 5 over 5. Square root 5 doesn't really look like it, but there you go. Now I also know that the cosine is 2 root 5 over 5, which means the adjacent and the hypotenuse, all right? So this is going to be 2 square root 5. And this is great because now, guys, I have everything I need. I'm good to go. I'm ready to get my trig functions. So I'm going to start by giving the original ones, the ones that we already had. All right, we knew that this was root 5 over 5. We knew this was 2 root 5 over 5. And then let's see what we have. Okay, so tangent. A couple of ways. You can take the sine and divide by the cosine, but remember, like, do you need to write the denominators? No, they're just going to cancel. Or the other way is you can just do y over x, right? Opposite over adjacent. So let's do that. Root 5 over 2 root 5. I would ask you to do what here, guys? Cancel out those root 5s and get 1 over 2. And let's see here. We need the reciprocal function. So let's go cosecant. And we need to do what? We need to just take the reciprocal. So 5 over root 5. Now this one, guys, I don't know if you remember. I would love it if you just knew that this was square root 5. Right? What is 5 made up of? 5 is made up of 5 is made up of root 5 times root 5. So obviously if I'm dividing by root 5, I'm going to be left with the root 5. We can use the same idea when we go to secant. All right? We're going to write it as 5 over 2 root 5. But again, what's going to happen with this 5 over root 5? Well, it's going to divide to root 5. So this is just going to be root 5 over 2. And lastly, cotangent is 2 over 1, or just 2. Now, please understand, I would not mark you incorrect if you wrote this, all right? I'm trying to teach you guys, and the AP is okay with you not rationalizing the denominator, so I'm okay with this. But it would be nice if you just had the math sense that 5 divided by root 5 is root 5. Okay? Okay. Let's move to the next page. All right, up at the top here. Oh, we have a nice easy problem here. Okay, find the exact value of the expressions without a calculator. Tan 20 minus sine 20 over cosine. Okay. This is interesting. I don't know my 20-degree angles, right? We know 30s, 45s, 60s, 90s, etc. So in this situation, we need to be super careful and see what is given. What do we know about sine over cosine? Sine over cosine is the same as tangent. So I, in this case, can rewrite this as tan 20 minus tan 20. And then do I care what tan 20 is? No. I know that if I start with a positive and then I take away, I'm going to get 0. All right? So this is an example of needing to know our identity that sine over cosine is tangent. Now, be very careful. I want to do one other thing that's not on the notes. So if we did tan 20 minus sine 40 cosine 20, I need you to understand that we cannot just cancel out or like take out a 2. All right? You cannot not use these identities unless the angles are the same. So put a big X through that and say angles must be the same. And hopefully you understand, like, I can't just change the angle, right? If I change the angle, that completely changes the y value, right? And that's what I'm looking for here. If I'm talking sine, I can't just pull out a 2 and then cancel like I was trying to do earlier, okay? So just please understand that this is only going to work if angles are the same. All right, let's keep going. Okay, we know that sine is positive and cosine is negative. All right, so let's draw this picture. Again, we know that cosine must be negative. So to help me out, I'm just going to kind of cross this off. I know I can't use it, right? I cannot be in the positive x direction. I do know that sine is 1 over 3. So if sine is, so y over r. Okay, all right, I think I have an idea of what I'm doing here. I know that sine must be positive, so I'm going up. I draw my circle, or not circle, my triangle, and I know this is y over r. Excuse me, y over r. So 1, 3. All right, I have a little bit of work to do here. I need to get the x-coordinate. I can use Pythagorean theorem. So 1 squared plus b squared equals 3 squared, or 1 plus b squared equals 9. B squared equals 8. B equals square root 8. Keep simplifying. Keep going. Keep going. 2 root 2. So I put a 2 root 2 here. Please be really careful on this, guys. It's going to the left. So what do you think I need to add to 2 root 2? Yes, I need a negative. All right, I need to show that it's negative. Now, technically, can we say a triangle should always have positive sides? Yes, I agree. I want the negative here so that you understand and you do not forget when we write our trig functions that the x-coordinate is negative. All right, so put that negative on there. And here we go. Sine, we already knew. Cosine, let's see here. Cosine, tangent, cosecant, secant, and cotangent. All right, we're ready to go. The easiest one for sure, cosecant, I know is just flipped, so there we are at 3. Cosine, we have an x. We have our hypotenuse, so x over r. Negative 2 root 2 over 3. Beautiful. Y over x, 1 over x, 2 root 2. Please be careful. What do I need you to understand? It is negative, okay? And we should also know that. Why? Because tangent has to be negative in quadrant 2. It has to be. It's a positive divided by a negative. I'm okay with you leaving your answer just like that, so don't worry about switching or anything. All right, for secant, I'm just going to use the reciprocals. So 3 over 2 root 2. And of course, it was negative, so it stays negative. And same thing with tangent. Negative 2 root 2. Now, for cotangent, remember, you can either just flip tangent, or you can say, well, if tangent was y over x, 1 over negative 2 root 2, well, then cotangent is x over y. So negative 2 root 2 over 1. All right? All right, last problem. We got this. We got this. Let's go back to purple here. Okay. Given that tangent is 1/2, and so I'm also wanting you to understand that it's positive, and sine is negative, find the rest of our trig functions. So I draw a little sketch. Okay, sine is negative, which means I can get rid of quadrants 1 and 2. Hopefully that makes sense, right? This is negative, so I need to be going down in the y direction. All right, tangent must be positive. Well, where is tangent positive? It is positive in quadrant 3. So let's think here. Tangent is y over x, which means my y value has to be 1, x value 2, so something like this. So 1 and 2. Now please be careful once again. I am in quadrant 3, which means I went to the left and I went down. All right. Let's get the hypotenuse. You can use x squared plus y squared equals r squared, or a squared plus b squared equals c squared. I don't care. But negative 1 squared plus negative 2 squared equals r squared. 1 plus 4 equals r squared. So it says r equals square root 5. All right, now that we always keep positive. Here we go. So sine, cosine, tangent, cosecant, secant, cotangent. We're getting there, almost there. All right. So sine y over r, negative 1 over root 5. Negative 1 divided by root 5. This is where I am completely okay with you just leaving this. Okay, I do not need you to change or rationalize the denominator. Good check here. Didn't we say sine was supposed to be negative? It's negative. Beautiful. Okay. Cosine. X over r. Negative 2 over square root 5. Easy, easy, easy. We got this. Tangent we already knew was 1/2. Negative 1 divided by negative 2 is 1/2. Beautiful. Cosecant. Reciprocal function time. Here we go. Just take the reciprocal of sine. Negative square root 5. Negative square root 5. Secant. Reciprocal of cosine. Negative root 5 over 2. And lastly, cotangent is 2. All right, so I am done with the video for now. I do want you to try one of these on your own. Very similar to 5 and 6. I want you to try this problem, and we will talk about it the first thing when we get to class. All right? Have a great day.